Hi guys, today we are going to finish the 7.7 factoring trinomials when a is not equal to 1 notes. The other day we started these, we completed our warm-up, and we started our slip and slide method, and we just need to finish going through these U-tries. Now, if you have not completed these last 4 U-tries, 3, 4, 5, and 6, I would pause the video and I would do those now. Okay, hopefully you've tried them. I'm going to go ahead and go through these so you can check your answers. So it's called slip and slide. I usually call it slip and slide and slip because we slip this 9 to the back. This gives us m squared plus 3m minus 18. Now, at this point, I need to find the factors of 18. So I can either A, write them all out, or B, write out just the one that makes sense. I'll write them all out for us. We have 1 and 18, 2 and 9, and 3 and 6. Now, this sign here tells us that they need to subtract to get positive 3. So 3 and 6 together will subtract to get positive 3 if the 3 is negative. So my factors at this point are m minus 3, m plus 6. Now I'm not done. That is the factor of this guy, not of the original. So now I need to slide a 9 back under. I need to reduce. Some of you guys were having problems figuring out how to reduce fractions. You guys basically just find the greatest common factor between each of these things individually. So in this case, the greatest common factor is 3. So I'm going to divide them both by 3. And I am left with 1 over 3 as my fraction. Same thing here. This one's greatest common factor also happens to be 3. They're not always the same. And I am left with 2 over 3. Now, I cannot leave a fraction in my parentheses, so I go ahead and I slip this 3 up. Actually, both of them are 3s. And I finally get my factored form 3m minus 1, 3m plus 2. So this is my solution, my factored form, what I'm looking for. If I were to multiply this back out, I would get back to the original, which is the whole goal, that the original and the factored form are the same. So we'll continue on. I'm going to go a little faster through the rest of these. Hopefully that just jogged memory. 10 gets multiplied back. We slide it back or slip it back. We get p squared minus p minus 20. The factors of 20 here that subtract to negative 1 are 5 and 4. The 5 must be the negative 1, so that way we get negative 1 when we subtract. So we have p plus 4, p minus 5. And then I have to slide the 10 back under. Now, both of these, like the last problem, do reduce. So I get p plus 2 over 5. And, I get p minus 1/2. Now, I do need to slip my denominator back up. So my final factored form is 5p plus 2, 2p minus 1. And this is my factored form. We'll continue on to question 5. I take my a term and I multiply it back, slip it back. I have a squared minus 4a plus 4. Factors of 4. That will get me to negative 4, R2 and 2. They will both have to be negative to get a negative 4 when subtracting and be able to multiply to get a positive 4. So I get a minus 2, a minus 2. I need to slide my 4 back under and reduce. 2 over 4 reduces to 1/2. Now, I have to bring this 2 back to the front on both of these. So I have 2a minus 1, 2a minus 1. Notice these are exactly the same as each other, which means when they're exactly the same, I write it once, 2a minus 1, and then I square it. And this is my completed factored form. Question 6 then. I multiply these 6 back, I get x squared plus x minus 72. My factor of 72 that I'm going to use, there are a bunch of them, but my factor of 72 that will get me positive 1 are 8 and 9. Because I need these to subtract to a positive 1, the 8 will be negative. So I have x plus 9, x minus 8. I have to slide the 6 under, reduce my fractions. I get x plus 3 over 2, x minus 4 over 3. I bring my denominator forward here, and I get for my final 2x plus 3, 3x minus 4. Now on all of these, if I distributed to check, I would get back to my original. That is a great plan to check your work as you go. Make sure you get the right answer. As for this new stuff, examples with greatest common factor, it doesn't really change very much. You look for a greatest common factor, you factor it out, and then you factor the remaining trinomial. So, this first one, the greatest common factor between all of these is 5. So I'm going to divide all of these by 5. This leaves me with 2k squared plus 15k plus 7. Now, yes, I still need to do the slip and slide method. There is an a value, so I will multiply the back by 2. So I now have k squared plus 15k plus 14. The factors of 14 that would add to 15 are 1 and 14. So this gives me k plus 1, k plus 14. I'm not done yet, though. I do need to slide the 2. The 2 back under. It's not the greatest common factor. It is the a value. I almost messed that up. This one does not reduce, so the 2 needs to go in front. So we have 5 times parentheses 2k plus 1. 14 over 2 does reduce, 2k plus 7. And that is our factored form. More steps here. We have slip and slide method as well as greatest common factor. For number 8, we can actually divide all of these by 2. They're all even. So I am left with 6x squared plus 1x minus 1. I do need to slip and slide because there is still an a term. So I slip the 6 back. I have 2 parentheses, x squared plus 1x minus 6. The factors of 6 that will give me positive 1 are 3 and 2. They will be subtracting to a positive 1. That means the 2 has to be the negative term. So we have 2 parentheses, x plus 3, x minus 2. Because I did use the slip and slide method, I do need to slide the 6 under. I will reduce my fractions to 1/2 and 1/3. And then I have to slip my denominators back up. So I have 2 parentheses, 2x plus 1, 3x minus 1. And this is my factored form. Guys, I want to point out that this is really no different than what we were doing before. There's now just a greatest common factor we have to take out. It's still just the slip and slide method with an extra letter or number, in this case, in front. Question 9, we can actually take a 3 out of all of these. So I'm left with 5y squared minus 6y minus 8. I do need to slip and slide, so I slip the 5 back. So I have 3 times y squared minus 6y minus 40. The factors of 40 are the ones that get me to negative 6 anyway. 10 and 4. One must be positive and one must be negative based on this sign here. And we got to get to a negative 6, so the 10 is negative. So I have 3 parentheses y minus 10, y plus 4. I have to slide the 5 under. The first parenthesis is reducible completely, so we have 3 parentheses y minus 2, because 10 divided by 5 is 2. The second one, we have to slip it back up, 5y plus 4. And this is our factor here. All right, last problem. I can take a 2 out of all of these. So I'm left with 16w squared minus 8w plus 1. Don't forget that plus 1 or else you're going to be in trouble. We do need to slip the 16 back. So we have 2 parentheses w squared minus 8w plus 16. The factors of 16 that will give me negative 8 when added are 4 and 4 if they are both negative. So my factors here are w minus 4, w minus 4. I do need to slip that 16 back under. These do reduce. They're both divisible by 4, so we have 1/4 left over. Remember, you must reduce completely. If you don't, it'll be wrong. We then slip the 4 back in front of the variable. So our final here, well, not actually final, I should say, is 2 parentheses 4w minus 1. 4w minus 1. Notice the 4w minus 1 is repeated, so we can actually just write it once. Keep that 2 on the outside and parentheses 4w minus 1 squared is actually our final. So make sure you guys finish filling out these notes, and that should prepare you for what we're going to do next. Have a great day.